All right, this is your Chapter 4 review and recap since I cannot be here today in person. So we'll start off with the difference between a definite and an indefinite integral. An indefinite integral is what we started the year with. So I'll go with an I for indefinite and a D for definite. An indefinite integral does not have any bounds, and you have something in here, dx, telling you that x is the variable. This is your antiderivative. Also remember that the indefinite integral will always have a plus c on the end, unless we can figure out what c is because we have an initial condition. And it will follow the opposite of the rules of your derivatives. Your indefinite integral will be a function. It'll have variables in it. It'll have the plus c on the end. The definite integral gives us bounds. A to b of whatever this function is, dx. That will give you a number. Your answer will be a single number. Remember that when we did our antiderivatives, we took our antiderivative, which let's say it's capital F of x, and evaluated it from a to b. Remember that we just plug in the upper bound minus the lower bound. And then we have our definite integral. For antidifferentiation, we had some basic rules. First of all, we had that power rule. If I have x to the n power, antiderivative dx, we just take x to the n plus 1 power, add 1 to the power, and divide by the new power, plus c. Other basic rules of antidifferentiation: the antiderivative of a constant times a function. Remember that you can just take that constant out front and then find the antiderivative of your function. We have the antiderivative of a sum or difference. You can break your antiderivative apart. So take the antiderivative of the first piece plus or minus the antiderivative of the second piece. Your antiderivatives of trig functions, the antiderivative of the sine of x dx is negative cosine of x plus c. The antiderivative of cosine of x dx, is sine of x plus c. Let's see, the antiderivative of secant squared of x dx is tangent of x plus c. And then there's obviously many, many more. We could get into the cosecant, secant, and cotangent ones, but these are the most common ones. Also, basic rules. We use our u substitution, right? If you can rewrite it as f of u du, we just have f of u, call that f prime of u du, f of u plus c, and then you substitute the u back in. And those are really our main antidifferentiation basic rules. Summation. Summation, remember, just means we are going to plug in values of I from 1 to 4, in this case, into 5i. So if I is 1, I plug that in and I have 5 times 1. Now I is 2, I have 5 times 2. Now I is 3, I have 5 times 3. Now I is 4, I have 5 times 4. This symbol here tells me that I am adding all of those up. So I'm taking 5 plus 10 plus 15 plus 20, which makes 50 as my final answer. Average value. We have a formula for the average value of a function over an interval. The average value formula was 1 over b minus a times the definite integral from a to b of our function dx. So that's what we'll do to find this average value. We'll take 1 over 4 minus 0 on the interval 0 to 4 of 3x to the 4th power plus x dx. So we'll have 1/4. The antiderivative of 3x to the 4th power plus x is 3x to the 5th power divided by 5 plus x squared divided by 2 from 0 to 4. We plug in 4, so I have 1/4 times, when I plug in 4, I have 3 times 4 to the 5th power divided by 5 plus 4 squared divided by 2 minus, plug in 0, 3 times 0 to the 5th power divided by 5 plus 0 squared divided by 2. And now I would say my calculator would be a handy addition. 3 times 4 to the 5th power divided by 5 plus 4 squared divided by 2. And that's minus 0 here. So I have 622.4 times the 4th, or divided by 4. I get 155.6 as the average value of that function over the interval. Then we had the second fundamental theorem of calculus. The second fundamental theorem of calculus gives us a function. F of x is the integral from 2 to x of 3t squared minus 3t dt. The second fundamental theorem of calculus tells us that the derivative of this function is just plug in that upper bound in place of t. So 3x squared minus 3x is the derivative, and that's what the second fundamental theorem of calculus says. Now, if this upper bound had been something more complex than just an x, we'd have to do the chain rule and multiply by the derivative of that at the end. Then we did some u substitution. So when it comes to u substitution, you need to start by finding something to be u. You want to choose something that's raised to a power, or inside a square root, or inside a trig function, something kind of like that. In this case, I would choose u to be my denominator, x cubed minus 8, because I think I can find the derivative of this in the original function. So du is 3x squared dx. Well, I don't see a 3 anywhere in this equation, so I'm going to divide that 3 over. So 1/3 du equals x squared dx. Now I notice that my denominator here is u. X squared dx is 1/3 du. So I have the integral of 1 over u times 1/3 du. To clean this up a little before I integrate, I would take that 1/3 out front, and I would call this u to the negative first power du. And I actually just realized I gave you a problem here that you don't know how to do yet. So let's pretend that in this original problem, this denominator was squared. All right, so that way this denominator was squared here, and this is a negative second power. So I just changed our original problem to x squared over x cubed minus 8 squared dx. I apologize for that. So now we add 1 to the power, it becomes u to the negative first power, divide by that power. My 1/3 is still out front, and stick a plus c on the end. All right, well that means 1/3 times negative 1 over u plus c. And now we just replace u. Negative 1 over 3 times u is x cubed minus 8 plus c. And there's our final answer. And finally, Riemann sums. Riemann sums, if I want to approximate the area bounded above by a function, below by the x-axis, and by the vertical lines x equals 0 and x equals 2 using 6 rectangles and the right-hand Riemann sum. You have a calculator program to do this. So just a quick refresher of how that works. In your calculator, you'll go to y equals, and you'll type in this function, negative 2x squared plus 3x plus 6. You can graph it if you want, but then we're going to exit out of that. Now you're going to hit your program button and choose the program. If you have a different calculator, you may have to press enter and then choose the program. But I want Riemann. You probably don't have quite as many formulas in here, but Riemann. It says program Riemann, press enter. Left bound. Well, we just said between 0 and 2, so that means my left bound is 0, enter. My right bound is 2, enter. Number of intervals, well, I want 6 rectangles, so I say 6, enter. This gives me 3 values. This problem said the right-hand Riemann sum, so I look at right sum 12.259. And there we have it.